Okay, this graph look familiar? It should, because we've gone over it already. So hopefully that helped everyone on this question a little bit. Okay, so first mark, what's going on in part A? Nothing. If they actually wrote nothing, I would prefer they wrote not moving, but nothing is accurate enough. Nothing's happening. The object's not moving. Okay. If they wrote constant velocity of 0 meters per second, that would also be technically correct. Okay. Anything that implies it isn't going anywhere would be fine as an answer for A. Okay. So that's 1 mark. In part B, the object is traveling at a constant, well, we want to say constant velocity. That's the most correct. I'll accept constant speed, but in the future, I will not. Okay, it is a constant velocity in a forward direction if we're being like perfectly thorough about this answer. Is what? Sorry. Yep, that's true. Yeah, I would like to see if you're going to write it that way that you add at a constant rate, something like that. Okay, C. Same answer as A. Okay. Well, it doesn't come to a stop. It is stopped. Coming to a stop looks different. Okay. What's going on in D? Moving backwards at a constant velocity or constant speed. Okay. In the future, I'd like just constant velocity. Okay. So moving at a constant velocity backwards, changing its position backwards at a constant rate, something like that. All right. And then the last part of this is calculate the velocity in section D. All right, if I want to calculate the velocity, I need the displacement divided by the time. Okay, so the time is that I go from 4.5 seconds to 6 seconds, which is 1.5 seconds. And I go from 60 meters to 20 meters. So my final position is 20 minus 60, and I get negative 40 divided by 1.5. So give them a mark if they have v equals d over t somewhere. Okay, and then the final answer, negative 40 divided by 1.5, is that it should be, we'll say, maybe they wrote negative 26.7 or negative 26.67, or maybe they wrote negative 27. Okay, I'm just going to write negative 26.7 here. So negative 26.7 meters per second. They either must have the negative or have written backwards, okay, or something that indicates direction, because velocity is a vector quantity and thus requires a direction. So if they don't have the direction, it's wrong. Okay, they got to have the direction there to get that mark. Okay, any other questions on number 1? Okay. So for question number 2, okay, we want to calculate the average speed of the object over its entire trip. Okay, if I want average speed, I need total distance over total time. Okay, so this is out of 6, but it's because you need to figure out how far it goes in each section of the graph. Okay, so in this section of the graph, it goes 20 meters. So if they have that written somewhere, I can give them a mark for that. Okay, it doesn't go anywhere during this part of the graph. Okay, during this part of the graph, it goes another 20 meters. And in this part of the graph, it goes 20 meters. Okay. All right, so 1 mark for each of those. Okay. 1 mark for this, for the 4th mark. Okay, and then we're going to have 60 divided by 12 seconds, which is the entire time. Okay, and we're going to have a speed of 5 meters per second. So that's the 5th mark. That's the 6th mark. Okay, there's no mark for the 0 because they didn't have to do anything for that part. Okay, so 1 mark here, 1 mark here, 1 mark here. Okay, there. If they just went straight to 60 over 12, still give them these 3 marks. They obviously knew what they were doing in terms of getting that. Okay. Yep. Okay, any other questions on number 2? All right, please give them a mark out of 12 at the top so they can see it. Okay, give it back to them, and then I'd like them in a nice neat pile right here, please.